In this lesson, we're going to show an example where you have to use logs in order to solve the exponential equation. So if we look at what we have right now, we have 3 to the 2x minus 1 equals 7 to the x plus 1. If I tried it using the first method, by finding the same base, which if you didn't see that, that's in the previous video lesson for solving exponential equations, I would try to rewrite 3 and 7 with the same base. Well, I can't because they're both prime numbers, so there's no way that I can rewrite them with the same base. When that happens, then we have to use logs in order to solve this exponential equation. So our first step would be, if we had only one exponential, we would isolate the exponential on one side of the equal sign. So for example, if I had 3 to the 2x minus 1 plus 4 equals 7. In this case, I only have one exponential. It would be 3 to the 2x minus 1. In order to do anything further, I would need to isolate the exponential, which would mean to move the 4 over first. But in our case, we have two exponentials, so we're actually going to skip that step. The second step in order to solve the exponential equation would be to take either the log or the natural log of both sides of the equal sign. Now there's a few notes that go along with this. The first is that it does not matter if you decide to take the log of both sides or the natural log of both sides, as long as you keep it consistent throughout. So if I take the log of the left side, I have to take the log of the right side. If I decide to take the natural log of the left side, I have to take the natural log of the right side. Your answer at the end will be equivalent no matter if you use log or natural log. Typically, I end up using log when I'm dealing with numbers like we have here, the 3 and the 7. So that's what I'm going to do, is that I'm going to be taking the log of 3 to the 2x minus 1, and then the log of 7 to the x plus 1. The second note is just that typically, to make our lives a little bit easier, is that if we had an e involved in either side or on both sides, we would want to take the natural log of both sides. Okay, so when solving an exponential equation, if you have that natural base e, you would want to take the natural log of both sides because it'll save you a step later. So the reason why we took the log of both sides is in order to solve for x. So what taking the log of both sides does is allows us to use the power rule in order to bring down our exponents. So we're going to bring down the entire exponents, and when we do that, we are going to end up putting the exponents in parentheses to show that the entire piece is being multiplied in front. So the 2x minus 1 is going to get dropped down in front. So we have 2x minus 1 times log 3. Equals, same thing on the other side, that x plus 1 is going to get dropped down, and the entire x plus 1 is the exponent is going to be multiplied by log 7. At this point, it's important to understand that this notation, the log, is your common log. It has an implied base 10. So log 7 and log 3 are actually numbers. You can put them in the calculator. You can see their decimal form. Okay, so the log 3 is going to stay log 3 throughout all the rest of the math that I'm going to do. Same thing, the log 7 is going to stay throughout. Because our next step then is to solve for x. So we took the log of both sides, used our power rule to bring down the exponents so that we can now solve for x. In order to solve for x, we need to get the x's on the same side of the equals. In order to do that, we're going to have to distribute. Okay, so again, remember log 3 and log 7 are constants, so I'm going to end up distributing each. So our log 3, when I distribute, this is going to end up becoming 2x times log 3 minus 1 times log 3. On the other side, I'm going to distribute the log 7 in the same way, so we're going to get x log 7 plus 1 log 7. Now 1 log 3 and 1 log 7, just like with x's, 1x is the same thing as x. You can get rid of the 1 in each case and just say that we have log 3 and log 7. That's entirely up to you. I just kept the 1 there so that way you could see how I distributed. We do also typically put the log 3, log 7, whatever the log is at the end, so that way we can see that the 2x is not inside the log and there's no confusions on that. At this point now we need to continue to solve for x. So what that means is that we need to get any of our logs that have x's on the same side and any of our logs that don't have x's on the other side. So I'm going to move over my x log 7 first, so that way I have 2 x log 3 minus x log 7 minus log 3 equals log of 7. And then next I'm going to move over my log of 3 because, like I said, I want to keep the x's on the left and then our logs that don't have the x's on the right. So I'm going to move over that log 3. So we have 2 log 3 minus x log 7 equals log of 7 plus log of 3. So anytime that we have two x's, right, we have 2x log 3 minus x log 7, those are not like terms. I cannot combine them. So what I need to do is to actually factor out an x. So that means on the left-hand side, we're going to have x times 2 log 3 minus log 7. The right-hand side is just going to stay the same. So log 7 plus log 3. All right, so anytime you need to go from 2x's to 1x, you don't have like terms, factor out the x. Our last step now is to divide both sides by this inside, because 2 log 3 minus log 7 is a number. Again, you can type that into your calculator. You can see what the decimal equivalent is. So in order to solve for x, we have this being multiplied, so the opposite of multiplication is division. So I'm going to divide by this 2 log 3 minus log 7. So that gives us an exact final answer of x equals log of 7 plus log of 3 all over that inside 2 log 3 minus log of 7. And anytime they're asking you for the exact answer, they want this. Again, if you use natural logs, you'd have natural logs everywhere that I have a log, and it would be equivalent. And then when you type this into your calculator, you'll get the approximate answer. So we would get approximately 12.11439573, and then this goes on for a while. A few comments about typing this into your calculator. You do need to put the entire numerator in parentheses and then the entire denominator in parentheses. And again, depending on how old your calculator is, when you type log, it might open up a parenthesis for you. Just remember to close it. So if I hit the log button at first and it opens it up, I type the 7 in, I need to close it again. Same thing with the log of 3. Every time that it opens a parenthesis, you need to close it. If you don't, then your answer is going to end up being different.